Hello learners, how are you all? I hope you all are doing well. I am Rekha Garg. I welcome you all in session 2 of chapter 1 Matter in Our Surroundings of class 9th. In this session, we will cover the topic states of matter. First, let us understand the targeted learning outcomes of the today's session. After completing today's session, you will be able to identify the different states of matter that are solid, liquid and gas. You will be able to differentiate between the properties of solids, liquids and gases. Before starting the session, I want to recapitulate some important points of session 1. In previous session, we read about matter. Anything that has mass and occupies space is called matter. Matter is made up of very tiny particles. The particles of matter have space between them. The particles of matter are continuously moving. The particles of matter attract each other. Diffusion is a spontaneous movement of a matter from a region of its high concentration to the region of low concentration. On heating, diffusion becomes faster. Now, let us observe different types of matter around you. It may be fan, bulb, glass of water, chair, etc. You can see that matter around us exists in 3 different states: solid, liquid and gas. These states of matter arises due to the variation in the characteristics of the particles of matter. Let us understand some important keywords related to today's topic. Rigidity. It is the property of the matter due to which an object retains its shape and size. Compressibility. It is the property of the matter due to which a substance is reduced to a smaller volume when force is applied on it. Fluidity. It is the property of the matter due to which a substance tends to flow. Kinetic energy. The energy of the particles of matter due to their movement is called their kinetic energy. Density. The mass per unit volume of a substance is called its density. Or we can write it as density is equals to mass upon volume, and the SI unit of density is kilogram per cubic meter. Now, let us study the properties of 3 states of matter in detail one by one. The solid state. To understand the properties of solid state, let us do a small activity. Collect the following articles: a pen, a book, a needle and a piece of wooden stick. Sketch the shape of the above articles in your notebook by moving a pencil around them.
बनाने के बाद उसके बाद आप सामने उसे दिखा दीजिएगा।
Now you can observe these pictures. Do all these have a definite shape, distinct boundaries and a fixed volume? You can observe that all these articles have a definite shape as they are not changing their shape. All these articles have distinct boundaries as they are not mixing into each other. All these articles have fixed volume as they occupy the same space. What happens if they are hammered, pulled or dropped? You can observe that the pen and the wooden stick will break, there will be no effect on the book and after a long time needle will break. Are these capable of diffusing into each other? You can observe the articles are not capable of diffusing into each other, or we can say that they cannot intermix into each other. Try compressing them by applying force. Are you able to compress them? You can observe the articles do not get compressed. From this activity, we can conclude that solid articles have definite shape, distinct boundaries and a fixed volume. They are rigid, but they may break under force. They have a tendency to maintain their shape and have negligible compressibility. Few examples of solids are salt, sugar, chair, chalk, etc. But the question arises, why solid shows these physical properties? To understand it, let us have a look on the arrangement of particles in solids. You can see particles of solids are tightly packed. Space between the particles is very less, due to which they have a strong force of attraction between them. This arrangement of particles makes solids to possess definite shape, distinct boundaries, fixed volume and make them rigid and incompressible in nature. Now just think about some situations. What about a rubber band? Can it change its shape on stretching? Is it solid? Yes, a rubber band is an example of solid. A rubber band can change shape under force and regains the same shape when the force are removed. If excessive force is applied, it breaks. What about the sugar crystals? When kept in different jars, it takes the shape of the jar. Are they solid? Yes, the sugar crystal are the example of solids. The shape of each individual sugar crystal remains fixed, whether we take it in our hand or put it in a plate or in a jar. What about a sponge? It is a solid, yet we are able to compress it. Why? A sponge has minute holes in which air is trapped. When we press it, the air is expelled out and we are able to compress it. Now we will study about the another state of matter, the liquid state. To understand the properties of liquid state, let us do a small activity. To conduct an activity, collect the following items: water, cooking oil, milk, juice and the containers of different shapes. Put a 50 ml mark on these containers using a measuring cylinder from the laboratory. Now observe what will happen if these liquids are spilt on the floor. You will observe that all these liquids will flow when spilt on the floor. Now measure 50 ml of any liquid and transfer it into different containers one by one. Does the volume remains the same? I have took the water which is stained already. Now put this solution into the jar. You can see the water have the same volume, that is 50 ml. Now we will choose another jar. You can observe the volume is still same. Now we will take the another jar. Now you will see the volume is still the same. From this activity, you will observe that the volume of the liquid remains the same, that is 50 ml, when it is transferred from one container to other. Does the shape of the liquid remains the same? The shape of the liquid is not fixed. It takes up the shape of the container in which it is put. So, when you pour the liquid from one container into another, does it flow easily? You will observe when the liquid is poured from one container to another, it flows. So, from this activity, we can conclude that liquids do not have fixed shape, but have a fixed volume. That is, they take up the shape of the container in which they are poured. But their volume does not change on changing the shape of the container. Liquids flow and hence they are called as fluids. But the question arises, why liquid shows these physical properties? To understand it, let us have a look on the arrangement of particles in liquids. You can see particles of liquids are loosely packed. Space between the particles is more than solids, due to which they have a weaker force of attraction between them than solids. Due to their particle arrangement, liquids do not have fixed shape as the particles slide over each other but have fixed volume, and they are not rigid and can flow easily. In the previous session, we learnt that solids and liquids can diffuse into liquids. The gases from the atmosphere diffuse and dissolve in water. The gases, especially oxygen and carbon dioxide, are essential for the survival of aquatic animals and plants. The living creatures need to breathe for their survival. The aquatic animals can breathe underwater due to the presence of dissolved oxygen in water. Thus, we may conclude that solids, liquids and gases can diffuse into liquids. The rate of diffusion of liquids is higher than that of solids. This is due to the presence of great space between the particles as compared to the solid state. Now, we will discuss about another state of matter, the gaseous state. Have you ever observed a balloon seller filling a large number of balloons from a single cylinder of gas? You have definitely seen. Isn't it surprising how he is able to fill so many balloons from one cylinder? Can you guess how many balloons is he able to fill from one cylinder? I guess it may be 20, 30 or more. To understand the properties of gaseous state, let us do a small activity. Take 300 ml syringes and close their nozzles by the rubber cork as shown in the figure. Now, remove the pistons from all the syringes. Leaving one syringe untouched, fill water in the second and piece of chalk in the third. Put the pistons back into the syringes. You may apply some Vaseline on the pistons before inserting them into the syringes for their smooth movement. Now try to compress the content by pushing the piston in each syringe. What would you observe? In which case was the piston easily pushed in? You will observe that the piston of the syringe containing chalk piece and water requires a large amount of force, while the piston of the first syringe, which contains air, is comparatively easier to push. From this activity, we can conclude that solids and liquids do not get compressed by applying pressure, but a gas can be compressed easily by applying pressure. Therefore, gases are highly compressible, liquids are almost incompressible, while solids are completely incompressible. The liquefied petroleum gas LPG that we get in our home for cooking or the oxygen supply to the hospitals. In the cylinders we compressed gas. CNG compressed natural gas. is used as a fuel these days in vehicles. Do you know why? It is used because of its high compressibility, that a large volume of gas can be compressed into a small cylinder and transported easily. Can you guess what is being cooked in the kitchen even without entering? Yes, you can know by the smell that reaches your nostrils. Do you know how this smell reaches us? The particles of aroma of food mixed with the particles of air spread from the kitchen reaches us. The smell of the hot food reaches us in seconds compared with the rate of diffusion of solids and liquids. Due to the high speed of particles and a large space between them, gases show the property of diffusing very fast into other gases. Now, the question is, why gases possess these physical properties? To understand it, have a look on the arrangement of particles in gases. You can see particles of gases are free to move. Space between the particles is maximum, due to which they have a weakest force of attraction between them. This arrangement of particles make gases highly compressible. The particles move randomly, due to which they can flow easily, diffuse easily, have high kinetic energy, but do not have fixed shape and volume. Let us recall the properties of three states of matter by comparing them through a table. Solids have fixed shape, whereas liquids and gases do not have fixed shape. Solids and liquids have fixed volume, whereas gases do not have fixed volume. Solids have least kinetic energy, liquids have higher kinetic energy than solids, whereas gases have highest kinetic energy. These properties can be explained as the particles are locked into place in solids, whereas they can slide past one another in liquids and free to move past one another in gases. Solids have negligible compressibility, liquids are almost incompressible, whereas gases are highly compressible. Density of solids is highest, liquids have lower density than solids, whereas gases have the least density. These properties can be explained as there is a little free space between the particles of solids and liquids, whereas there is a great deal of free space between the particles of gases. Particles are closely packed in solids, whereas less closely packed in liquids, and particles are free to move in gases. Interparticle force of attraction in solids are strongest, weaker in liquids and weakest in gases. These properties can be explained as the particles of solid cannot move or slide past one another, whereas particles of liquids can slide past one another and particles can randomly move past one another in gases. I hope now you have understood the properties of solid, liquid and gas. Let us check your understanding. Can you tell me the state of matter in which the material takes the shape of the container? The correct answer is liquid. Can you tell me the state of matter in which the material cannot be compressed? If you guessed it solid, yes, you are right. Solid is the correct answer. Can you tell me the state of matter in which the material does not have fixed shape and volume? Yes, I know you have guessed the correct answer, and the correct answer is gas. Can you tell me the state of matter in which particles are strongly attracted to each other? Yes, the correct answer is solid. Let us take some multiple choice questions. Question number 1. Why is compressed natural gas CNG used as a fuel these days in vehicles? Option A, large volume of a gas can be compressed into a small cylinder. Option B, due to its high compressibility. Option C, easy to transport. Option D, all the above. The correct answer is option D, all the above. Question number 2. The aquatic animals can breathe underwater due to. Option A, the presence of dissolved nitrogen in water. Option B, the presence of dissolved oxygen in water. Option C, the presence of dissolved carbon dioxide in water. Option D, all the above. The correct answer is option B, the presence of dissolved oxygen in water. Question number 3. A few substances are arranged in the increasing order of forces of attraction between their particles. Which one of the following represents a correct arrangement? Option A, water, air and wind. Option B, air, sugar and oil. Option C, oxygen, water and sugar. Option D, salt, juice and air. The correct answer is option C, oxygen, water and sugar. Question number 4. Choose the correct sequence on the basis of arrangement of particles given. Option A, solid, liquid and gas. Option B, liquid, solid and gas. Option C, gas, liquid and solid. Option D, liquid, gas and solid. The correct answer is option A, that is solid, liquid and gas. Now, there are some questions for assignment. Write them in your notebook. Question number 1. Give reason to justify. Water at room temperature is a liquid. An iron almirah is a solid at room temperature. Question number 2. Why can't solids be compressed like gases? Question number 3. Liquids generally have lower density as compared to solids, but must have observed that ice floats on water. Why? Question number 4. How will you show that air has maximum compressibility? So, learners, today we will end this session here. I hope you have understood the concepts taught in this session. In the next session, we will cover the topics change in states of matter by the effect of change of temperature and pressure, evaporation and the factors affecting evaporation. Till then, bye and keep shining.